differentiate this and find out when its gradient is 0. So any tidying up needed? Well, just rewrite that as 2x to the power of minus 1 before we begin. And differentiating, that bit's fine, that's just 2. And this bit here, times by the power, makes a minus 2 x to the power of minus 2. Find out when that is 0. So I've got 0 equals 2 minus 2x to the power of minus 2. Now it's one of those moments where this is looking a bit strange, so why not change that back into the x squared part of the bottom there. So it's 2 over x squared. Now, if we times everything by x squared, we can get a much nicer form of the question. I'm going to take out a factor of 2 there. In fact, we'll divide by 2. And it gives me x squared take away 1, which can factorize into x minus 1 and x plus 1, giving me answers x equals 1 and x equals minus 1. Again, we could use our calculator to check this thing, couldn't we? So let's, actually we just clear that. Bring up the differentiation again, and what we were differentiating was 2x plus 2 over x. And we're thinking that the gradient when x is 1 there should be 0. It does indeed give 0. And what about changing that to a minus 1? Indeed, that gives 0 as well. If at that point there you were struggling to solve that equation, remember you could have used your equation solver. 0 equals 2 minus 2x to the power of minus 2. Tapping that in as I've seen it there, choosing Shift Solve and taking a first guess at the answer there, and it's given me that the answer there was x equals 1. Of course, it only gives me the one answer. If I'd actually done Shift Solve and made a guess here at, say, I don't know, at minus 5, then it might have got me to the second answer. No, that's ended up getting me to the same answer there as well. So finding out that second answer might have taken a few other guesses. Maybe if I try 0.5, I don't know. No, they're all going to 1. So you might have needed to get the other answer through the algebra.